So let's review how we solve rational equations by hand, and then we'll take a look at some of these answers using technology. So remember that we want to get a fraction equal to a fraction, which means we want to get these two fractions on the left-hand side together, and we're going to do that through the use of a common denominator. So first we have to figure out what our denominator is. So this denominator factors into 2 times a minus 3, and this next denominator factors into a minus 3, a plus 3. So our common denominator, or our least common multiple, is going to be 2 a minus 3, a plus 3. So this first fraction needs an a plus 3, top and bottom, and the second fraction simply needs a 2, top and bottom. So let's take a look at what we have. So we have a times a plus 3 minus 6 all over the common denominator, 2 a minus 3, a plus 3. And that's equal to a minus 2, and I'll take the opportunity to also pull out the GCF of 2a plus 6. That's 2 times a plus 3. So now that we have that, the easiest way to do a problem like this is to get both of these denominators to match, because remember that when both these denominators match, then I can sort of forget about them. I don't care about them anymore. I can just set the numerators equal to each other. And so what I want to do now is multiply top and bottom by a minus 3. And that's going to allow these two denominators to be the same. So let's take a look at that down below here. I'll take the opportunity now also to distribute. This side is going to be, I'm going to have to FOIL that or box it out. And so that's going to be a squared minus 5a plus 6 all over the common denominator. So it's at this point that I don't care about the denominators anymore. Now I can just set the numerators equal to each other, which actually turns into a fairly easy problem here. It's a fairly easy problem because I don't need those a squareds anymore, and I'll get 8a equals 12. So the answer must be 3 over 2, 1.5. Let's take a look at some problems now using technology. And the easiest way to do this is to separate these into two different equations. And what I mean by that is I could take one equation, call it y equals 2 over x minus 1, and then I could take a separate equation, call it y equals 3 over x plus 2. Keeping in mind that we need y's and x's in order to graph, and there aren't any y's in this original equation, but I'm going to separate these into two separate pieces. Let's go to Desmos and let's take a look at what this looks like. So I have these two equations, separate equations graphed here. And what are we looking for? We are looking for a point of intersection. And so if I tap on my graph, I get a little dot there, and notice that I get an ordered pair, 7, 1/3. And the question is, what are we looking for? Well, we're looking for the x value. So even though we got the ordered pair, 7 comma 1/3, what I really care about is the 7. So the solution to this is 7. And if we were to plug that in, we could see it. So I did this on purpose. I selected a fairly simple equation for us to take a look at. And if x is 7, let's take a look at it. 2 over 7 minus 1, does that equal 3 over 7 plus 2? Yeah, we're going to get 3 over 9, and we're going to get 2 over 6, both of which reduce to 1/3. That 1/3 is not a coincidence. If we plug in x, we'll plug in 7 for x, we'll get 1/3. So the key here is that the solution we're looking for in a graphic sense is where the curves intersect. And also notice here that there could be multiple answers. In this particular example, there was only one answer of x equals 7. Let's take a look at another example. So let's take a look at this on Desmos. And you can see that I have those two equations entered. And let's take a look at their intersections. So just tap on your graph and you'll see you get 1, 1 and negative 1/2 comma negative 2. And once again, we only care about the x values. So x is equal to either 1 or negative 1/2. And if we plug them in, we will get a true statement. Let's just take one moment and do that. 2 minus 1 over 1 squared equals 1 over 1. It's pretty easy, right? So you're going to get 2 minus 1 equals 1. Absolutely. The next one's a little bit harder. Let's plug in negative 1/2. So here's a deal where we're going to have to flip and multiply. We know what happens when we divide by a fraction. We've got to flip and multiply. So that's 1/4 when we square 1/2. And this is going to be negative 2 when I flip and multiply. So this is going to end up being 2 minus 4 equals negative 2. Also a true statement. And so we can see where those ordered pairs are coming from in Desmos. 1, 1, negative 1/2, negative 2. And finally, let's take a look at our last example, which is actually the same as the first example. I just took all the x's, I took all the a's and made them x's. And so once again, we're going to have two separate equations. So one equation is one side of the equal sign, and then the other equation is the other side of the equal sign. So I take these two separate equations and I graph them in Desmos. So there's my two separate equations. And remember, we've already solved this by hand, so we already know what the answer is, and we know that there is only one answer. And that answer is right there. I'm zooming in a little bit so we can see it. We tap, there it is, 1.5, 1.5. We got 3 over 2. So that is the same as what we got when we solved that by hand, 1.5 or 3 over 2.